Hello friends, now in this video we're going to be continuing our lectures on the rules of logarithm. We're going to be continuing from where we stopped in the previous video. Now here, if we are given log x raised to power a base x, log x now raised to power a base x, what this would give us would be a. According to the rules of logarithm, this would give us a. So you can see it clearly from there now, because we know that if we have log x now base x, and this would be raised to power a, so raised to power a. From the previous video, we know that this a goes behind the logarithm, right? So we will have a log x base x, and we know that from our previous video, log x base x would always give us 1. So this is how we get a. So now we can have numbers such as log 3 base 3. Now this 3 here will be raised to power 5, and according to the rules of logarithm now, this would always give us 5. This would always give us 5. Now the next rule we're going to be discussing in this video, we could be given the question whereby we have to change the base, change of base. Now let's assume we have log a base x, now, and we are asked to change this to base a. Now what we are going to have there is that we are attempting now to switch these two, because we have that this would be a now being here and the base is x. Now I want to make a the base and x be the value. So what we do, according to the rules that helped us understand logarithm, is that we simply take the reciprocal and we swap the bases. So this gives us 1 over log a log x now base a. That's what we're going to have in the aftermath. So this is what we have in this sorts of form, right? So wherever we see these sorts of things now, questions to the extent of probably you are given log 5 base 2, and you are told to change this to base 5. This would simply give us 1 all over log 5 now at the base, right? 5 at the base, then 2 right here. So this would be what we are going to have in the aftermath. Now moving on, the next law we're going to be talking about now would also be change of base. Would also be a question whereby we have to change bases. Now we have to change bases, change of base, but this is quite different. How so? Now let me show you. This would give us, assuming now we're given log a base x, and we are told to change the base to base y. Change it to base y. How do we go about this whole piece? Now in the previous one, the value in which we were to change the base to was part of the logarithm now, but here now we are asked now to change this to an entirely different value, which would be y. So what happens, like I usually tell my students, is that you put an imaginary division line here, and you can evaluate this in that format. So what this would be is that we're going to have log a all over log x all over log x. And remember, this is just a little trick I'm trying to show you. Remember that we are told to change it to base y, right? So we put y here and we put y here. So this is how we can change that value, right? That's logarithm to base y. So you could be giving questions to the extent of log 3 base 7, and you are told to change to base 5. So what you have here is that this would give us, remember our imaginary division line we have to place around here, right? So this will give us log 3 base 5 all over log 7 base 5. And just like that, we have been able to change the base, right? How true, very true. Now in the next one, we are given, let me write number 4 right there, number 4. So we could be given log a base x now, and this would be raised to power y. Log a base x raised to power y. Now, how do we evaluate this whole piece? What happens now is that this power at our base now move behind the logarithm. This power at our base moves behind the logarithm, and it doesn't just move. We actually have to take the reciprocal of it before moving it. So we're going to have 1 over y. Are you getting it now? So we took the reciprocal of this power and we move it behind the logarithm. This gives us 1 over y log a base x. So this is what we're going to have in the aftermath. Now we could also be given log a base x raised to power, this x now being the base would have a power of 1 over y. X being the base, we have a power of 1 over y. How do we evaluate this whole piece? Now this would give us the very same thing applies. We're going to take the reciprocal of this power of x now, so that the reciprocal of 1 over y would be y. So this will give us y log a base x. So what happened there was that we took the reciprocal of this power and we moved it behind the logarithm sign, So that's what we are going to have in the aftermath. Now the last one we're going to be talking about now, would be a situation whereby we are given a raised to power log x now base a raised to power log x base a. And what this gives us, that is, in every situation we are going to be left with x. So this would always be what we are going to have. That's my time, guys. Now in the next video we're going to be solving some questions now that will help us understand the concept of logarithm better. Thank you so much for watching. See you in the next video.